Hello, everyone. Thank you for coming. So this week we talk about the visitor pattern. So that's the only topic for your week number 11 lecture. I do have a good collection of questions from Google Doc, mainly from Amir and also Vin. Thank you for contributing. So I'm just going to go over the questions, but as usual, you're welcome to interrupt me if you wish by chatting or just speak up about any follow-up questions. All right. Let me just go over with the order I've selected. Let's just go over one by one. Okay, so starting from just clarification about when to use the visitor design pattern. Okay, let's go over the question quickly. Okay, this one I believe is from Amir. So the name about visitor actually comes from the fact that we want to traverse through all the items in the data structure. I think that's pretty accurate. Basically, think about whenever you want to talk about the visitor pattern, the assumption is you already implemented the structure part using the composite design pattern. Remember when we talk about this, the visitor design pattern for the expression language, right? You actually got two clusters over there. So one is about the structure, right? And also you got another cluster over here that's called visitor. Right? So you should really think about, you might just get a structure part and only support. Okay, think about this. You want to use the visitor if, okay, number one, there is already a composite design pattern implemented for the recursive data structure. So already, composite implemented. And especially remember, composite design pattern is really suitable for recursive system, right? Recursive. And this is number one. And number two is really important. Remember when we talk about the composite design pattern in week number 10, so the example we use is the computer equipment manufacturing system, where we only want to know about the price if you're given some composite object for the computer equipments. In that case, if there's only one operation you would like to figure out from the recursive structure, in that case, you may not need to go over the trouble with visitor. Okay, so the visitor, there's one very important precondition if you wish. So visitor is really about multiple operations you want to support. Multiple operations to support. So here, the term multiple here is really important, okay, about multiple. If there's only one operation you would like to support on the recursive data structure, like a price, in that case, you don't really have to go with the trouble for the visitor, right? So, and the way you can think about is, whenever you got a visitor cluster over here, you're going to get a top level class called visitor, right? And then the number of descendant classes you want to have under the visitor depends on how many such multiple operations you want to support. If you just want to support just one operation, in that case, you only got one single descendant class, then that might be overkill of using the visitor pattern, right? That's something I'd like to clarify, all right? But the first one is pretty accurate, except that you want to know that it's really about, in a data structure, I would say recursive data structure. So that'll be more important to identify, all right? And then it's about, can we review this pattern again? Because somehow Amir cannot distinguish from the composite design pattern. So Amir, are you okay with the explanation so far? Do you think that's enough? Or you want to go, I don't think that you want to go to, you're not really asking to go over the visitor completely. You just want to know what the difference is between the two, right? So the difference between composite, let's just go over here. Okay, let's just see some concrete diagram. If you look at the architecture for the visitor design pattern, so this is the diagram from your slides, okay? So this part is the composite, and this part is the visitor. So how do you tell the difference? The difference is the composite part over here, so this is the composite. The composite is just about give you the ability. So the ability to build recursive objects. For example, you can see this part over here, it's about using the composite design pattern, right? So this fragment of code is also the example we went over in the lecture. So you can see this part here, we can simply use the constant, we can use addition, we can use, oh, sorry, I actually highlighted too much. Let me just do it again. Only this part here. This part here. You can think about this part here is really using the composite. You can see this part here, we're simply using constant twice and using addition. That's how we build the recursive structure, right? That's about a composite. On the other hand, when you talk about visitor, it's about having given any composite structure, for example, at. You can see this is one of the composite structure. And then you can simply use the a.left.accept. So this one is really using the visitor pattern. And whenever we talk about visitor pattern, it's really about you got some top level visitor class over here. You can see this is your visitor class over here, under which you got as many operations as you like. As I said before, it should be actually multiple operation you're talking about. It should be multiple. If you only got one single operation, then it may not be necessary to really implement a visitor pattern. All right, so Amir, if you're here, so can you just let me know if this is okay for you? Just about the distinction between composite and visitor. Are you okay with this? If you want to follow up with anything about the distinction. All right, so hearing none from you, so I suppose you're okay, right? Because your question is really about the distinction between the two, which I already explained. All right? Okay, so seeing none from the chat, let me move on to the next one, right? So far, I only talk about just the distinction between the composite versus the visitor. So these are two separate patterns, but they're very related to each other. So you want to don't want to lose that big picture, all right? All right, so that's about the composite and then versus visitor. Let me go to the next question, all right? So the next question is, I think this is from Vin. I would like to verify that if I want to implement a multiplication class, I must be aware that I will need it. Okay, so basically Vin is referring to, let's say, this particular structure, composite structure over here, right? So this is what you're given, and then we got expression under which we got the base case being the constants. And then for the recursive case, we only got addition. Let's say that's the language we like to start with, all right? So now, as we mentioned before, let's just review one part over here. Let's say this is really the structure we would like to have. And then remember the open-close principle that's applied to the visitor design pattern, which we explained in the lecture. So I'm not going to repeat it. Basically, we're just saying that in this case, the structure part should be closed. And also, this visitor part should be open, right? Why is that? Let's just review that very quickly. Let me just go to the particular page over here. Okay, let's take a look over here. Just very quickly. So this is also some illustration we did in the lecture. So think about what's going to happen if you try to add a new components to the structure part versus when you try to add a components to the operation part. Let's see what the consequence might be. This might be a nice review for you. Let's say this. According to the open-close principle, for the visited design pattern, we know that this part here should be closed. And this part over here should be opened, right? So now, if you actually want to add a new language construct, right? So basically, this is what Vin was asking, right? When you actually first built this particular structure cluster, you really want to have your idea very clear about how the language structure should really look like. You shouldn't really be like that. It shouldn't be like, let's say after I have built this particular cluster here, but I keep adding new components to it. Because every time, for example, if I want to add multiplication over here, for example, here I say multiplication over here, so that should be effective. So that should be a descending class of composite and also a descending class of expression, right? The multiple inheritance. So now if I do that, so that means I will violate the single choice principle, meaning that it's not the only class I'm going to modify, but also I need to add accordingly in the visitor cluster over here. I'm going to say visit and then multiplication and then or whatever argument that's necessary, right? And then that'll be deferred. And that will also consequently, I need to also make sure this particular visit modification is also implemented in every class that's a descendant of the visitor, right? So I also need to say visit modification and also visit modification. And also visit modification over here. So what's the difference between these three over here? If you look at that, this one, and this one over here, this one is really about as far as the evaluation is concerned. So this one here is going to visit, is going to traverse the composite structure and then do evaluation. And this one here is going to traverse the recursive structure and do pretty printing. And this one here is going to traverse the recursive structure and do the type checking, right? So you can see there's so many multiple places you will have to change just for the sake of adding a new language component. You can see adding each one of them is going to be very costly. If you only do that rarely, that's acceptable. But if you do that constantly, so that means the original pattern of visitor should not be adopted in the first place, right? Okay. So this one, if you simply do that, is going to violate single choice principle. Single choice principle, as we explained. All right, any questions so far about if you're trying to add a new language components over here frequently? In that case, that means you're violating the single choice principle frequently. So that means your visitor design pattern shouldn't be adopted in the first place, right? That's some design decision you have to make. Any question about this? Everybody is okay? All right. And then on the other hand, since that, let me just repeat again. So you can see this part over here is closed, which means this part should be rather stable, okay? And then this part here is open. So that means this part can be subject to extension or changes. So now if you want to add maybe some new operation, that means we're adding to the open part. This will be okay. So this is going to make sure you're still satisfying the single choice principle. If you're trying to add a new operation, let's say code generation, right? In that case, what you will have to do is you're just going to add a single class over here, maybe call that code generation. Right? It's a new class, descending class at the same level as evaluator, pretty printer, and also type checker. Right? And then in this single class over here, we're just going to implement all the visit operation or the visit commands. So you're going to implement the visit constant and also the visit addition. So that's what you have to do. So these two in a single class. So that's why single choice principle is satisfied. There's only one single class you have to touch. So that's satisfying the single choice principle. All right, any question about satisfying or violating single choice principle in the visitor design pattern? Any questions? Is everybody okay? Okay, I presume everybody's okay here. Okay, I don't see any questions in the chat. Let me just move on. All right, so let me just go a little bit further to this question over here, right? So now, in his original question, if this is the language structure you have over here, right? And let's say the original one is simply just over here without the modification. So I would say, if you know eventually you really want to support the modification, you should have included in the original design over here, rather than adding that later. So in your very first working version of the system, you want to include the structure part to be as complete as possible, because adding 80 new structure part into this particular cluster, every new addition is going to violate the single choice principle once. So you want to make sure this part over here should be as complete as possible, okay? So let me write it down as a comment to Vince's question over here. Okay, let me just say this part over here. So my response will be, you want to make sure the structure cluster here should really contain as many classes as possible in your initial design. The structures cluster in the first working version of the system should contain as many classes as you can anticipate. Okay, that's number one. Okay. Otherwise, if you didn't try to make the cluster as complete as possible, every new addition of the class about, for example, modification, subtraction is going to violate the single trace principle once, right? Otherwise, each addition of a new structure class, for example, modification, right? Modification will violates the single trace principle, right? So this is more like a guiding principle about if you really want to implement a visitor design pattern in your particular project. In that case, you really want to make sure the initial draft about your structure cluster over here should be as complete as possible. Okay, it's a very important guiding principle that you should really bear in mind if you want to implement a visitor design pattern. All right. There's another thing I want to show you, just draw some connection over here. So to be more practical, the expression language that we talk about in the lecture is pretty primitive, pretty elementary, just for illustration purpose in the lecture. However, I just want to tell you that, for example, last year when we did the projects, we actually gave students a different design problem. Well, for this year, you do this Space Defender 2. In that case, you may have some recursive structure in your system, but it's not a very big part. But last year, what we asked the student to do was to implement some language processor. In that case, we give them more like a language, like a subset of the Java language. And then you have a class, you got attributes, and also you got a very simple structure of the methods. And then, so this is just, for those of you who are in the CS program, you learn about context-free grammar, right? Context-free grammar. So now you can think about this is just part of the grammar that the student would give in last year's projects. And then here you can see different cases. You got integer constant, and also you got Boolean constant, right? So these are like the base cases. On the other hand, you also got, for example, binary operation. You also got a unary operation, and also you got some call chain. It's like a method call, basically, or access to the using the dot notation. And here we got plus, minus, multiplication, division, modulo, conjunction, disjunction, equivalence, larger than, less than, right? You can see, realistically, your structure cluster can be way more complicated than the example we did in the lecture, so realistically. However, the bottom line is, if you decide that you're going to use the visitor design pattern, you want to make sure in your initial draft of the system, this part here should be as complete as possible. You don't really want to update your language grammar or components over here too often, right? So that's the bottom line I want to mention, okay? So this part here is really outside the scope, but I just want to give you some context, all right? Okay, let's say we got a question from Nora. So if we have the classes beforehand, the design is not considered to violate the single trace principle. Yes, okay. So basically, Nora, you're right. So think about, let's say this. While you're developing the first working version of your project, let's say for the language processor, right? Let's say if you anticipate the only operation, the only structure for the language we will need will be just constants and also addition. If you believe that's the case, in that case, you shouldn't include anything else. However, if you do anticipate, we're going to need all the arithmetic operations that might be, all the arithmetic structure that might be needed later, for example, addition, multiplication, division, and also modulo, for example, then you should have included them while you're developing the first version. You should. Otherwise, as you said, right, every new addition is actually going to violate the single choice principle, right? Sorry, I'm just going to go back to that particular page, right? Every new addition over here is going to violate the single choice principle once, right? So you're right. So the initial version here should be as complete as possible. Right? So Nora, make sense to you? Or you need some further clarification? All right, good. All right. All right, guys, so far so good. Okay, we just talked about the architecture for the visitor design pattern, right? I think it's more about for every design pattern you're thinking about to implement, you want to know whether the design context is really applicable for that particular design pattern. If it is not, you'd rather not use it, right? So for example, if your project is so that the structure part is always under changes, in that case, you'd rather not using the visitor design pattern. Okay, that's something very important. All right, so that's about the question. Okay, so I think I answer that's Amia's question that's answered, and also Ving's question is also answered. Okay, let me move on. All right, another one over here. This one also just some clarification. I think this is from Amir as well. So there is some correlation between the clauses in the expression cluster constant addition to the commands of expression operations cluster, the visitor cluster, basically. Yeah. What he's talking about is like this, which we also spoke about. You can think about, in principle, under the visitor class over here, the number of visit commands you want to have depends on how many effective classes you have under the expression class, right? For example, over here you can see visit constant over here correspond to the constant, and also the visit addition correspond to addition over here, right? So if you got more the effective classes over here, for example, you also got modification. So that means you also need to put modification over here, right? So there's such correlation, yes. That's part of the description for the question. Let's go back. And then, while the expression language is really close, yes, the language, the structure cluster is really closed, and we are not going to make changes. Then being open in the expression operation cluster means what? It means this particular scenario, okay? So you can think about it's really this particular scenario we're having. The reason that we want to use the visitor design pattern is because we want to really get the list of commands over here being fixed, right? Because we want this particular part to be closed. We don't really want to frequently add any new language structure components into this cluster. So this part here should be closed, meaning that the list of commands over here should be also closed. Having said this, what does it really mean when we said this cluster is actually open? So that simply means we are able to add as many descendant classes as possible under the visitor. So every time, for example, we add code generation over here, we just create a class, and then we just want to make sure we implement every command in this particular fixed list of the commands over here, right? Right? And then you can add as many as possible. You can simply got another one. For example, I can create another one over here. Maybe we got code generation. Maybe we simply got maybe, let's say, we got pretty printer over here. Let's say we got another one. Let's say save to database, for example, right? You want to make sure whatever expression language you have, you can also save that to some remote database. In that case, it would be just another class you're creating, right? So you can create as many classes representing different operations as you like. So that's really the beauty about the visitor pattern, because every addition for the new class you add is not going to violate the single choice principle. It's going to obey it. All right. Okay, so a very quick response to it. Okay, means what? So that means you can add as many descendant classes or subclasses, descendant classes of visitors of the visitor as you like. Okay, that's number one. You can add as many as you like, and then each new descendant class you add that's the single point of change. That's the single point of changes. Of changes. All right. Any question about this? We're still surrounding about the ideas of when you actually got a visitor design pattern, so what should be changed and what should not be changed, right? That's very important. We haven't talked about, like a runtime, how the double dispatch is going to occur. We might talk about it today, right? We will. All right, any questions about this? All right, everybody's okay? All right, okay, don't see any new chat on the, don't see any new question on the chat. Let's move on. Okay, so this one here is from Vin. Basically, he tried out the tutorial I sent to you guys. Okay, I think, again, this tutorial over here, let me just show it to you. Okay. All right, so if you go to week number 11. Okay, so there is some recommended tutorial over here. So you can see the tutorial is about the composite and visitor design pattern. So that one there really shows you how to really program that, in EVALUATOR. So that's something I will recommend you actually try. That can really strengthen your understanding about the visitor design pattern. And then basically got some question related to the double dispatch, which I would like to clarify, maybe by running the code in EVALUATOR. So basically the code, I'm not going to make it available to you guys because I think it would be very important for you to try it out, the tutorial from scratch, so you can really type out the code yourself. That'll be the best way for you to learn, okay? But you can also feel free to enter the code that's from the slide. That can also work as well, all right? So let me just show you what I have over here to give you some idea. And the tutorial example pretty much corresponds to what you saw in the slides, okay? Let me just go to EVALUATOR over here, okay? Okay, so now EVALUATOR, you can see we got two different clusters. We got structure. You can see we got expression, we got composite, we got addition, we got constant. I think I also got subtraction, just another class in the structure in the tutorial. And then under operations, we got evaluator, we got visitor, right? You can think about the visitor actually got two descendant classes. We got evaluator and also pretty printer. Currently, it's not really used, but I'm going to illustrate that also as well. Let's just focus on the evaluator first of all. Okay, so what I would do is I'm going to, first of all, show you something here. So you can see that here, but the structure we have is basically like this. Okay, you can think about the structure we have is we also got another class over here in the first draft. So we're not really violating single choice principle. It's already there. Okay, so we also got subtraction over here, right? That's also inheriting from here, right? And then under the visitor, we actually got evaluator. That's what we got. We also got pretty printer, but I'll speak about this maybe a little bit later. Okay, having that structure in mind, let me show you some easy tests. I just want to show you in the debugger how things work, especially about the double dispatch. That's really that's very crucial to the visitor design pattern. So if I go under the tests over here, go to test operations. Okay, and then you can see this is the test. Okay, that's actually from the tutorial. And then we simply got some expression over here. We got constant, we got addition, pretty much like the setup in your lecture. And also we got some evaluator over here. Okay, notice one thing here. So this part over here, we're just creating the composite objects, right? We already went through the example in the lecture. Unless you got questions, otherwise I'm gonna assume you're okay. So there's a composite, and then we got this particular evaluator. Okay, so now the question is, what will be the dynamic type for the evaluator, right? That's something we have emphasized many times. When you actually don't have the curly brackets over here, it will be as if you simply put a line like this. It will be as if you did that, right? So that means we got evaluator, eval, the static type is simply evaluator, and its dynamic type is also evaluator. This is why we don't need to write it as a syntax convention, right? Okay, everything still compiled. And then to really use the visitor design pattern, we have to say the composite object E1, and then we'll simply say accept, right? You can see E1 over here is actually of type simply expression, okay? What's the dynamic type for E1? Dynamic type is actually constant, so which means we're gonna accept using a constant and then accepted by evaluator, right? What I want to show you is the next one. So let's say we got A1 or A2. We can see A2 over here is A1 and A2 are both additions, right? They're of different structure. Let me take A2 for example. So when I try to do A2 that accept, think about how double dispatch is going to occur, right? Let's do that together in EVALUATOR. So what I would do is, first of all, I'm going to set a breakpoints. And then I'm just going to drag it over here. And then if I just put a breakpoint over here, let's say just around over here. So it's right before I call a.to.accept eval, right? So now if I run the debugger, let's see what's going to happen. So now I'm actually pausing at this point over here, right before I try to execute a.to.accept, right? Based on what we learned, if you refer to the lecture, I simply execute the line on the paper, right? But now let's try to see the double dispatch from a different angle, okay? So now in order to make this routine call, right, we are basically calling the accept. So this is going to be the so-called double dispatch, meaning that dynamic binding is going to happen twice, right? The first time, think about dynamic binding simply means you're going to call the correct version of the routine, right? Based on the dynamic type of the context object over here. So now what's the dynamic type for A2, right? So you can easily check it. You can see A2 over here. You can see the type is simply addition. You can also use the instance of equivalence in iPhone. You can say, for example, attached over here, addition, and then A2. You can see that's true. On the other hand, if you try attached constant A2, this one is false. So that means dynamically A2 is really an addition object. So now the first dynamic binding is going to make sure when I step into this particular accept, it's going into the accept, the version that's really in the addition, right? That's according to dynamic binding, right? That's the first dynamic binding that's going to happen. So now if I say step into, right? You can see now I'm in the accept under addition, right? That's the first dynamic binding. Any questions so far about the first dynamic binding, the first one? All right, that's the first one here. And now let's see the second one. You can see under the accept, basically the implementation from the supplier side will always be standard. You basically want to make sure the argument visitor over here, you can see statically, is simply just visitor. Dynamically, what can it be, right? According to the diagram we saw in the lecture over here, if the static type for visitor is simply just a V is simply visitor, that means dynamically it can be any of the descending classes. In this case, it will be evaluator and also pretty printer. Okay, but in this case, it's actually evaluator dynamically, right? How do we know? Let's now go back to EVALUATOR and do some similar check over here. So now you can see it's V over here. So now if I simply type under expression V, you can see now the type is simply evaluator. So I can just do a similar instance of check. I can say attached, let's say evaluator. Oh, sorry, attached evaluator. And then I should say the one I want to check is V. This one is true. So that means dynamically, let me make it a little bit wider for you. Dynamically, V is of type evaluator, dynamic type. On the other hand, if I try this, attached, and then I will put pretty printer. This will be pretty printer. I think the reason that we got error over here is because remember in the beginning, the pretty printer was grayed out. It's not currently being used in the compilation. So for this one, error is actually fine. But later on, once we introduce the pretty printer back to the system, you will see that. For now, we can just omit it. That's fine. That's fine. All right. So now we know that dynamically, evaluator is really V is really dynamically an evaluator. So now it's going to be the second dynamic binding. If I say step into, I'm going to make sure the correct version of visit addition is going to be called. If you again recall the diagram we have over here, how many versions of visit addition do we have? For this particular project, we actually got, you can see we got visit addition over here under pretty printer. We also got visit addition here under evaluator. So now dynamic binding is going to make sure it's going to call only one version that's corresponding to the dynamic type, right? Let me go back there. If you go back there, you will see over here, because V dynamically is really an evaluator. So now if I say step into, I'm now going to step into the visit addition over here. That's actually under the context of evaluator, okay? If I simply do that, so now you can see it's a visit addition here, and then it's under evaluator, right? So now under evaluator, I'm going to do whatever that's necessary, right? Remember in the lecture that we talked about when I traced the dynamic binding, I said that it's going to be another instance of double dispatch over here. When I say a.left.accept, and also when I say a.right.accept, it's going to be another instance of the double dispatch. So that's something you really want to convince yourself how exactly that's going to happen, right? In other two instances. All right, so that's about the double dispatch in EVALUATOR. Okay, any question about this? Any point you want me to clarify? I got another part to illustrate because Vin does ask that. Okay. Any questions? All right, assuming that everybody is okay. So now let me just go back to Vin's question there and I'll continue from this, okay? So let me simply just go back to Vin's question over here. Okay, let me just go back there. Okay, good. Okay, so first of all, his question was why the dynamic type is actually evaluator for V. The reason is, okay, let me just point there. I already explained that in the demo. If you look at the test operations, you can see this is the line, create, eval, make, right? Implicitly, it would be as if we say create, curly brackets, evaluator, eval, make. So that's why dynamic type for eval should be evaluator. All right, and then let me just go on with the question. When he said he couldn't find a line over here would be create, eval, make, right? That's something you can refer to. And then, so this is important. Is it because evaluator is the only class that has the visit constant effective, so evaluator automatically becomes a default type when it is called? No, this is quite a misunderstanding over here. Even though there is only one class right now. Remember when I go back to the EVALUATOR over here, you can see the pretty printer over here is actually grayed out. It's not really part of the system just yet. However, that's not how you understand it. The reason that the visit addition in the evaluator is being called is because in the test over here, if you look at this again, when we actually say create, eval, make, so this is where we create the evaluator objects dynamically, and then we are simply passing eval to a.to.accept. So this is why dynamically eval is simply evaluator, is because how we created that. It's not because evaluator is the only class that's under visitor. It's not the right reason. Right? I want to clarify that. Of course, to further clarify, I'll add in the pretty printer in just a moment. Okay, let me just finish the question. Okay. Okay, so here, what if we have the pretty printer class? How can the second dispatch decide which one you will call the visit constant? That's exactly how I would like to illustrate. All right, let's see this. Let me just try to program a little bit. Okay, not really completely, just for illustration. You can see currently we got pretty printer over here. It's gray out. How can we make it blue? So it's actually part of the compilation. Let me go to test operations over here. And then I'm just going to introduce a new type over here. Let's say pretty printer. Let's say PP. You know what? Let me make it even more interesting. Let's say V over here. Visitor, right? So statically V is simply visitor. All right. And then let me just write some new line over here, right? So now if I say, and then I'll say creates. Now, so now I cannot say, for example, visitor, and then v.make. Can I say that? Visitor over here. Hopefully every one of you will see that this is not possible, right? Because if you go to visitor over here, it's actually a deferred class. You can never create a dynamic type based on a deferred class. So this is not possible, right? If you simply try that, it's going to tell you creation is really referring to some deferred type. So that's not allowed, right? It's not just in iPhone, it's also in Java, right? Okay, let me come back here. So now dynamically, let me just put pretty printer, for example. So now dynamically V is really a pretty printer. And let me compile. Let's see what the constructor is. If I go to pretty printer, I haven't got any constructor yet. Let's define that. Okay, let's do that. Let's say for the sake of illustration, let me do the following. So I would say create. I want to have a command called make. I want to use it as a constructor. So I would say feature. I would say attributes and commands. Okay. Normally, you should really split them into different feature sections, but for now, just put it into one. So now let's say, remember I also said in the lecture, let me just remind you again. If you actually go back to this architectural diagram over here, we said that in the evaluator class over here, we don't really know what's going to be the traversal result for each kind of visitor. For example, from the evaluator, since we want to evaluate the numerical expression into some integer, so we might simply declare a new value over here of type integer. And for pretty printer, most likely it's going to print out some string output. So that's why here we might just declare some new feature, new attributes called value, and then of type string. And then for type checker over here, we're going to do value maybe of type simply Boolean, meaning that either is type correct or not type correct, either way, right? So you can see even you can see different types over here. So it's difficult to simply just put something over here, simply a value. It would be a very poor design if you simply say value of type any. So this is a very poor design. Because if you simply do it, that means every time you want to retrieve this particular value, you want to do something about it, you actually have to do a lot of casting. So this is something we said already. It's a bad design attempt, all right? All right, so now we're just assuming that for evaluator, for pretty printer, for later on, if I want to add more classes, you will just need to define some result over here, and then like a value of the correct type, right? Let me now do that quickly for the pretty printer. I do see some question there on the chat. Let me get back to you in just a moment. Okay, let me finish this, and I'll get to you. Okay, so now for the pretty printer, I can say value of type string, right? Again, notice the contrast over here. If I go to evaluator, you can see I do have also like a value, but it's like an integer, right? It's different types, right? Depending on what kind of visitor you're talking about concretely. Now, if I go to pretty printer over here, it's simply string. And then let me just have the constructor command. I can say make over here. Let me just evaluate that to be empty string. Create value dot make empty. Let's just make sure, okay, everything compiles. And then over here, what about the implementation here? Let me just do something over here, but you should really, when you follow the tutorial, there's some exercise you should really try to do, all right? So I can simply say, I can say the value of string is simply going to equal to assign to something. I can say, maybe I'm now in the pretty printer dot visit constant. So this will be enough for my illustration about double dispatch, just enough. Okay, and then value over here is pretty printer class and then visit addition. So I would know at the runtime which version of visit addition I'm calling, right? That's something I'd like to illustrate. And then we got value over here, pp dot visit subtraction. All right, let's make sure everything compiles. Okay, good. So now what we have is under the visitor, we got both evaluator and pretty printer. You can see pretty printer is actually blue, right? It's part of the compilation. Let me go back to the test class. Test operations, go back here. And then we got, basically we got a pretty printer. Okay, let's see this. Yeah, create pretty printer v.make, good. So now, let's now do something very similar to this line, but now I want to illustrate that double dispatch even further, okay? Let me try this. If I simply say a2.accept, and then I simply got, let's say v. By the way, there's something I will leave you to also to look at, right? If you remember in the lecture about how we use the visitor design pattern, okay, let me just show you one thing here. You can think about what I'm doing here is very similar to what we did in the lecture. So v here is really statically a visitor. So now if you simply say v dot value, this is not going to compile because the value over here is not really declared in the visitor class statically, right? You can only go with the expectation on the visitor static type. So that is why we need to do some cast over here. So the cast will be, we want to make sure that the V is really an evaluator cast to it, and then call it eval. So that's why I can say eval the value over here, right? So that's something you want to pay attention to, right? But I'm not going to demonstrate the cast. That's something we already covered in the lecture. Let me focus on illustrating dynamic binding and also double dispatch. Let me go back here. So now what I will do is I'm going to illustrate for this particular line. And then from now, I'm just going to go with the dynamic type of V being pretty printer. And later on, I'm going to illustrate to you what if I change the dynamic type, right? So it's going to change as well. Let's do one at a time. So let me just, again, put a breakpoint in that line. Okay. Let me move that a little bit higher. Okay, let me remove the previous one. Let me, did I accept? Okay, sorry, over here. Did I compile? Let me just do once more. Okay. Okay, everything compiled. I want to put exactly A2 to accept. Okay, let me just do it again. Okay, let me drag and drop over here. Okay, exactly here. I just forgot to compile. Okay. Okay, so now we want to do the same check again, right? A2 to accept, right? Let's try that right away. You can see over here, now I'm at this point. Let me just make it even cleaner for you. Okay, let me just do it from scratch. All right, so now we are right at this point. We want to know what the type is for A2, right? That one we know already knows addition. Let me just double check. Okay, you can see attached, addition, and then A2 over here. So that's simply true, right? So the first dynamic binding is not difficult because A2 dynamically is addition. So now if I say step into, it's going to call the version of the accept that's defined in addition, right? That's the first dynamic binding. So if I step into it, so now we got the accept over here under addition, right? What about the second one? So now, what could be the dynamic type for V? Potentially, it could be either a pretty printer or evaluator. But now, for this particular case, if you simply say V over here, it's actually, let's look at that, it's actually a pretty printer over here. Let's check more precisely. If I say attached, pretty printer, and then V, it's actually true. On the other hand, if I say attached, evaluator V, it's actually false, right? So for this particular one. And so now if I say V the visit addition, so now the dynamic type of V is actually pretty printer. So that means it's going to call the visit addition that's in the pretty printer class, right? That's something we can anticipate. So now if I say step into, I'm going to get a visit addition from pretty printer, right? You can see that's exactly the line I just coded, right? All right, any questions so far about the dynamic binding for this case, double dispatch? Think about for each double dispatch, you got two dynamic bindings that's gonna occur in sequence. So now to complete my answer to Vin, I would like to do one more illustration. So now what if I still keep this line the same? However, I'm just going to change this part over here. Let's say, what if the dynamic type of V over here is not pretty printer? What if it's evaluator? So now, which dynamic binding is going to change? The first one or the second one? That's the question. Anybody? If I change this from pretty printer to evaluator, so Vim, if you're here, you can answer me. So now if I change this, am I going to change the behavior for the first dynamic binding or the second one? Okay, Nina said it's the second one. How about Vin? You're the original person to ask this question. You want to confirm if you're there? The second one, good, right? The first one has not been changed because it's simply A2, right? Unless you change the dynamic type for A2. All right, let's just be complete. Now, if I say run, oops. Let me just recompile. I'm not too sure why this happened. Let's just do it once more. All right, so let's clean and then compile and try to recompile from scratch. Okay, just bear with me. Yeah, I think basically one of the there are two things you want to understand very well for visitor design pattern. Number one is about architecture and also when to use it, which you already covered. Number two is about the double dispatch at the runtime. So now if I go back to that particular test, okay. So now, by the way, pretty printer simply go back to gray. That's kind of you know what? Let me just still make it blue. Otherwise, it could be confusing to Vin still. Let me go back to test operations. How about I say here V and also V2, all right? And then what I will do is I'm going to say over here, creates pretty printer and also V2. V2 make. All right, so these are the two. And now notice that I got two different objects over here of type visitor. Dynamically, V is the evaluator and V2 is pretty printer. The one I just showed to you is about really like a passing V2 over here. But now let me pass V, right? You can see both classes are still in the system, right? So now let me set a breakpoint and do it again. And then we'll be complete about this illustration. Let me just put a breakpoint over here. This line, all right? And then I would say run. Okay, we're pausing over here. Well, you should know very well, A2 is dynamically simply just addition, right? So now if we step into, we are now really in the accept under addition, right? So now, Ring's question is now, are we only getting one choice about getting into which version? No, we actually got two choices. But now, which choice about which choice to really go for depends on the dynamic type of V, right? So now, if you look at V over here, you can see it's an evaluator objects. So now, if you try to step into over here, it's going to be the visit addition under evaluator, right? So you got two scenarios over here. Either you might go to pretty printer, or you might go into evaluator. Depends on what the dynamic type is for the visitor objects. All right. So Vin, does it answer your question on the Google Doc? All right, very good. I want to make sure. Okay, guys, that's about the illustration. Again, for this optional tutorial, even though it's optional, but I do encourage you to really try it out to see how to program the visitor design pattern. Let me go back to my iPad, and then I will see if there's any question on the chat. Okay, let me just move this guy here. All right. Okay, so one question from Nina. In the evaluator, why does a.left.accept uses double dispatch if it's already in the evaluator class and eval left of type evaluator? Okay. Basically, I just need to go for this particular part. Okay. Let me clarify the context over here. Okay. You can think about in the class, in the lecture, I explained to you about how the double dispatch can occur for at.accept, right? The first one is going to make sure we go to the accept for addition. That's the first one, right? And the second dispatch is we want to go to the visit addition that's in the evaluator over here. Okay, so that's the first dispatch, double dispatch, right? And then let's think about what's going to happen here. As I explained in the lecture, so if I say a.left.accept eval left, okay, let's clarify the context over here. You can see a.left over here is basically an expression. And also eval left over here is basically, dynamically doesn't evaluate it, I know, but I'll just say it's a visitor. Whenever you have any line like this, when you say expression, some expression type, dot accept, and then you have some visitor as arguments. So this will always trigger a double dispatch, always. A double dispatch, all right? And previously, the blue one triggers this double dispatch over here. Now the orange one is going to trigger another one. How is it going to happen? It's actually one of the exercises I wanted you to do in the lecture. But let's do it together just for the first one. Okay. So the orange one, first of all. So from let's ask Nina then. So Nina, let me ask you this. Let's say we are trying to do a.left, which is an expression that accept eval left. This is going to trigger another double dispatch. Let's just go very step by step. What's going to be the first dynamic binding? How is that going to occur? If I execute this line, any idea? This line over here. How is the dynamic binding going to occur over here? Yeah, anybody want to help? Okay. Eval left should be done first, not quite. Whenever we say dynamic binding, we really say we want to call the correct version of the routine, right? Anybody? Again, the question is, when the initial double dispatch over here triggers another double dispatch, which will be starting from this particular line. And now I claim that to be a double dispatch, meaning that there will be two dynamic binding that's going to occur. But now what's going to be the first one? Okay, this is one expression, and this is just another visitor. More precisely, think about the diagram here. A.left. You can think about A over here, the left is really pointing to this particular object over here, right? That's A.left. Tempeh said addition should be the first. Also wrong. According to my diagram over here, what's A.left? A here is referring to addition here. So in this one here, when you say add the accept, it's going to go for the accept that's in the addition. That's okay, because add is really pointing to the addition objects. However, right now, when we say A.left, right, what should that be? So Nina, are you following so far? That's really the question you were asking. Are you following so far? Or you're still struggling? I just want to see. Constant. Okay, are you sure? All right, so over here, you can think about over here, A.left over here really has the dynamic type. According to the diagram, is really about this constant here. So that means we're going to call the accept from constant. Right? That's what we're going to do. All right? And then this one over here is going to trigger the second dynamic binding. What about the second dynamic binding? Anybody? What about the second one? Let me help you a little bit. Since we are making a call over here that accept eval left, which means eval left is going to be passed over here. So this part here is really eval left. All right, so Nina, over to you. So now, how is the second dynamic binding going to occur? How is that? How is that going to happen? The second dynamic binding. Evaluator, all right. The V over here is really the eval left that we are talking about. And here, the eval left, dynamic type, you can see the eval left. How do I know that? The eval left over here, somehow the code over here simply omit. They should have been created already, right? About evaluator. That's something I simply omit. So this will dynamic type should be just evaluator. All right. So that means when I say v.visit constant over here, so that means what I'm going to do is I'm going to call the visit constant from evaluator, which will be this guy over here, right? Just follow the color I'm trying to do over here. Okay, the orange one basically will be starting from here and then go for the accept, and we'll call the v.visit constant, and because v dynamically is an evaluator, so we'll call visit constant over here, right? And for that one there, do we have any further double dispatch? Do we or do we not? Well, you can see this one here is simply see the value. You can think about this is the base case. No further double dispatch. All right. So Nina, does that answer your question about another double dispatch? Okay, very good. Yeah, so guys, just for your information, the orange one is just another double dispatch, right? So far we talked about two. This is the first one. Starting from here, this is the first one. And this is the second one. There will be another third one. I'll highlight to you the starting point. The starting point for the second one, sorry, the starting point for the third one. Let me just write it down more explicitly for you. Think about this guy over here. This one here is the first double dispatch, right? And then this one here, okay, this one here is the second double dispatch, right? What about the third one? I'm going to use green. The third one is going to be a.right, right? A.right over here, you can see a.right is also going to be dynamically some expression type, and also eval-right. Also dynamically is going to be of some visitor type. So this will be the third double dispatch. So we got 3 in total in this case, right? If in constant we call v.visit addition, that we will run into overflow, right? You are basically saying some wrong implementation. Let's see this. In constant, you mean here? Are you saying over here?
Yes.
Template? Okay, good. Let's try. Okay, if you're saying that, we'll simply say a good question actually. So what Tempe was suggesting was an alternative implementation. Let's say alternatively, v dot. Whether we're going to go into overflow like an infinite recursion, we don't know yet, but we'll see. Visit addition. Okay, and then we got current, right? Anybody want to give some reasoning? Okay, guys, here's a question. What's going to be the consequence if we simply say alternatively in the constant over here, rather than saying, okay, let me be more precise. Inside this constant over here and under the accept, rather than saying v.visit constant current, we say v.visit addition current. Are we going to run into infinite recursion like a template set, like a Stack Overflow, or something else? Template, since I wrote it out, the line over here, do you see, would you change your mind? Nina said runtime error. Are you suggesting that it will compile and allow you to run? That's what you mean by runtime error, or something else? Nora said compile time error. Nora, that sounds more promising, but why? Why do we get a compile time error? Because the type is addition, exactly. All right, let's double check. Very good. Okay, so this one here, okay, let me just point it out. Alternatively, so this will give you some compile time error. Because if you look at visit addition, remember the architecture here. When I say visit constant, the argument type is going to be constant. If I say visit addition, the argument type is going to be addition, right? So that's why the current over here, more specifically, the current over here is really referring to the current that's in the constant, right? So now the current is really referring to this, right? Let me draw the connection. So that's why you got compilation error. So template doesn't make sense. It's a compilation error. It's not a Stack Overflow. Good. All right. That's a good question. All right. All right, guys. Any more question about double dispatch?
So another question for this. So any advantage we can take from this? Because I mean, a.left.accept evaluate left. It's actually calling the visit constant. I mean, the method inside the class. So why don't we just call the?
Good question. Template, the reason that we wouldn't simply just say simply call a.left a visit constant. The reason that is, in general, you don't know how complicated a.left is. Remember the diagram I drew in the lecture. Let's do it again. In general, let's say this is A, which is addition, right? In general, you got left, and also you got right. This can be just some arbitrarily complicated tree structure. This can be just arbitrarily complicated tree structure, right? In general. The specific example you're given could be, for example, if you're simply given, for example, 2 plus 3. So now this will be the left, and this will be the right. In that case, calling visit constant will be okay on the left and on the right. That's okay. However, in general, it could be that, for example, we might get maybe 2 plus 3 plus 4 plus 6, right? Think about if this is really A. So this will be A dot left. And over here, this will be A dot right. So A dot left is simply conceptually 2 plus 3 and 4 plus 6, right? Let me just draw it more clearly. Okay, let's just do that particular example. Let's say A dot left is simply just another addition. And then we got left and right, and also we got constant 2 and 3. And the right will be just another addition at, and then we got 4 plus 6, right? So that's just another possible input. So in this case, what you were suggesting is, what if we change this one to simply A dot left dot visit, or we simply eval left dot visit constant? It's not going to work, because now, given this particular runtime structure, if you simply say visit constants, of course, v dot visit constant, and then if you simply say over here A dot left. Okay, think about what's going to happen. Again, Tempeh does a question for you. When I say v dot visit constant over here, basically you're suggesting that if I can just copy this line here, just copy this fragment, just make it clear to you. It's a good question. Let's say this, just for this line. Rather than saying this, I'm just going to say eval left dot visit constants. And then I'm going to say A dot left. So there are two things I would like to say about this particular alternative. Number one, conceptually, it wouldn't be enough, because A dot left could be as complicated as it might be by the user who wants to use your visitor pattern. So this part over here just cannot be handled by visit constant. That's from the conceptual point of view. Are you okay with that, first of all?
Yes.
Good. Number two, even more embarrassing, okay? Will this line even compile though? You want to think about it? I think that's also important. I like the question. If I simply say eval left over here, eval left, first of all, let's do part by part. Eval left is basically one of the visitors, right? And if you see that eval left is like an evaluator, it does have visit constant. However, it's expecting constant, right? Let's remember that. Let me just put the relevant fragment over here, right? So if you think about this particular line, okay, think about this. When we talk about visit constant, it's expecting some C of type constant. I'll say const. That's number one. But what's the static type for A dot left?
I think it's the attribute of the class, right?
According to the architecture diagram, what's A dot left static type? Where's the left attributes?
It's the expression, yeah.
It's expression type. Agree? So that's why I said, in general, you cannot assume left or right is simply just a constant. In some cases, maybe, but you cannot assume that in general. In your visit addition class, sorry, in your visit addition routine, you want to consider all the general cases, which means as general as any arbitrary expression. All right, let's go back there. And now, so the other part of the story is, okay, so visit constant over here from visitor. And then another part of the story is from your composite expression class. Okay, let me write a little bit better. Expression class, you actually got the left, right? Left is of type expression. And we're basically going back to our polymorphic arguments lecture, right? So now thinking this way, a.left over here, the static type is expression. Can you pass expression to when you are expecting some constant? Can you?
No.
No, because remember the rule. You can see again. So that's why review of the inheritance is so important. We're expecting constant. You can only give either constant or its descending classes, but expression here is simply not a descending class of constant. So this will not even compile. Okay, so now, no, does not compile. Because a.left has the static type expression, which is not a descendant of what's being expected constant. Okay, Tempe, makes sense to you?
Yes.
Okay, very good. I think that's a good question. I think it's really important for you to always, when you're given some basic fragment of code, either from the lecture or from the tutorial, you always want to play with them just by making some changes. Of course, the best way to find out would be to see if they'll compile and then if that runs. All right? Very good. So guys, any more question about the double dispatch or the runtime for a visitor before I move on? Any other questions?
So I just want to, so we are using the double dispatch because we want to do the calculation recursively, right? We want to touch.
Okay, thinking this way, double dispatch is a very special scenario for just a visitor to some pattern. So let me give you a little bit tip over here. Let's say either in the quiz or in the exam, whenever I talk about double dispatch, you would know I'm really talking about the visitor design pattern, right? Of course, when you talk about other design pattern, later after you graduate from this course, there might be other design pattern which will also trigger double dispatch, right? Not for this course, number one. Number two, how can you tell if there's a double dispatch? Whenever you see in this particular form, you got expression, which is a composite objects, and then you call the accept, and then you pass some visitor. This will be the starting point of a fresh double dispatch. However, since the tree structure for the composite objects can be arbitrarily complicated, so that means you might get more than one or two or three, depending on the structure of the tree. You might get multiple instances for the double dispatch. For example, in our particular example over here, you can see under the addition, we got constant. So this one here will trigger the double dispatch over here. And then when we get to the left, it's going to trigger another double dispatch over here. And we go to the right, you can trigger another double dispatch over here, right? Got three. If your tree structure for the composite gets more complicated, you might just get a larger number of double dispatch instances. Does that answer your question?
Yes.
Good, very good. Wei Ming got some question here. Why eval left doesn't need to create construction to create the objects? Yeah, this is something I said in the slides. I simply just wanted to save space. So I think if you follow the tutorial video, for sure. For example, you can see this. Right? Let me just show you here. If I did I close it? I think I closed that already, right? Okay, I'll just show you quickly if you don't mind. Oh, actually, it's here. Okay, there we go. Let me show you quickly. If I go back to the tutorial example we did together, you can see over here in the test, you can see we got, let me go to evaluator. I think that's where I want to go. In the evaluator, we got visit addition. You can see we got eval left, we got eval right. And you're right, we definitely have to create them first before we can call accept on them. Otherwise, you get void targets for sure. But again, in the lectures, just for conceptual illustration, I didn't really create them just for to save space. But if you want to do this for your personal personal projects, you have to create it for sure. Otherwise, the compiler will complain for the void safety problem. So what do you mean? Does it answer your question? All right, good. All right. All right, let me go back. We still got about 10 minutes or so. Let's hopefully to go over another 1 or 2 questions. Okay. Okay, I think I got only one left. Okay, so guys, I got only one question left. That one wouldn't take too long. It's more about a clarification for open-close principle. Okay, so now before I get to the final question there, do you have any more question about visitor in general? Architecture, applicability, design context, or runtime? Any more question about it? Anybody? Everyone's okay? All right. Let's now go to the last question here, also asked by Amir. I think it's a good question. It's always good to be critical about whatever you're being taught. It's also good to have a critical mind. If you don't think a particular design principle is very practical, try to justify why you don't think it is practical, and then we can exchange ideas. I think that's important, okay? Amir thinks the following. He doesn't think the open-close principle is actually practical to follow, right? Remember, let me just remind you very quickly about open-close principle, right? Basically, let's say you have your system conceptual like this. Okay, it's like a box of, think about initially you simply got a Superman module to begin with, and then you want to decompose that into different modules. Let's say that's in your entire system, right? Somehow you want to identify part of your system. So in practice, you don't necessarily have to apply the open-close principle to the entirety of your system. That may not be practical, because in order to satisfy open-close principle, some part has to be open and some part has to be closed. You don't necessarily have to go to every part of your system and decide whether that should be open or closed. Only choose like an orange part over here. Okay, I'll write it down over here. In practice, choose only a part of your system that is subject to the open-close principle, meaning that this particular part is not really subject to open-close principle. Let me be very clear, right? You can think about the blue part over here is simply just other parts of your system that's not really subject to open-close principle. So this part here, the part of your system not subject to open-close principle, right? So this part here, you don't have to worry about satisfying open-close principle. Only the part you decide to commit to the open-close principle. And then in the orange part, we want to now, since you decide the orange part should be subject to open-close principle, now let's decide which one should be closed and which one should be open, right? So you may decide, for example, maybe this part here should be open. You know, let me just try to be more careful here. I still want to keep the orange over there so you can see that. So maybe you want to say this part here is actually open. Okay, open here, and then maybe this part here should be closed. And this part here should be closed. All right, just a clarification. You don't really have to make every part either open or closed in your system. Choose a part of your system, and then from there, choose subparts that should be open or closed. Okay, just clarify. That's how you make it more practical. All right, and then let me just go. So Amir was more talking about how to apply open-close principle to the project, the Space Defender 2. All right, I would say number one, if you want to argue about whether your projects or your design really satisfy open-close principle, number one, you don't really need to argue that the entire system satisfy open-close principle. Only choose a part of it, and then for that particular chosen part, argue that subpart of it is open and subpart of it is actually closed. Okay, number one. And number two, let me read his arguments over here. I'm always changing all the parts for the objects, even the very first objects I created. What he's saying is, let's say this: if I decided that for this particular subsystem, this part should be open and this part should be closed. However, while I'm developing for phase 1 and phase 2, I'm always changing the open part over here, and also I'm always changing the closed part over here, right? Basically, I think that's what Amir is trying to say. Should this still satisfy the open-close principle, I would say it would be premature to judge only when you are still developing your projects, okay? Let me tell you why, okay? Let me say this. In the course of implementing a working version, you're not really subject to open-close principle. Not yet. Open-close principle, meaning that once you decide this part should be open and this part should be closed, you can think about, for this part over here, the orange one, right? You can think about open-close principle starts being effective after some working version of your system is done. You can think about it's like a version number 1 for your system, let's say when you're done with your some working version. Before you can make your system even working, you're not really quite subject to open-close principle because you want to make sure the open part has been implemented correctly and also the closed part has been implemented correctly. After that, you can be subject to the open-close principle. But before that, of course, it makes sense for you to always change the open part because you're still developing it. And also, you can always make changes to the closed part because you're still developing it, right? So Amir, that's my first response to you, all right? And then, how do I decide to draw the line between open and closed? I think that that's more about the specific design decision you have to make. For example, I'll just make some example for you. So for example, when we talk about ornaments and also enemy type, right? So you want to think about, do you want to keep the ornaments open or closed? Do you want to keep the enemy type open or closed? It's really up to your design decision, okay? For example, let's say for enemy type, okay? You want to say over here, open if you anticipate more enemy types to be added, right? In this project here, we simply tell you there are certain number of enemy types over here, but you want to think about for future extension, do you really anticipate any new enemy type to be added? If so, that part should be open. Otherwise, it should be closed. And similarly to the ornaments, right? Currently, we simply say ornament, simply got orb, and also we got focus, right? And then for the focus, we got either for carrier, for fighter, or for pylon, I believe, right? So you got different sizes for the focus. And also for the orb, you got either silver, you got either the bronze, silver, or gold, right? So do you want to support any other kinds? If you believe the ornaments might be also subject to changes, in that case, that should be open. Otherwise, it should be closed, right? That's kind of the design decision you have to make. All right, so finally, I want to just draw attention to this particular diagram. That's something I already said. I want to make it even more concrete for you. Think about the horizontal axis over here is simply the time. Let's say this is starting point of your projects. You want to move towards the end, okay, which can be can be unlimited, right? Because you might still work on the same projects in your workplace, for many years or something like that. And then the vertical axis is really about where to make the changes, right? You can see the green part over here is the open part. Okay, let me just annotate it. So the green one here is really the open part, and also the pink one here is the closed part. Okay, and then you can see that I try to draw a very clear cutoff line over here to say this is the point where you believe your system is working. So how do you know if your system is working? Maybe you have run through so many acceptance tests on your projects, or maybe you simply already got given eventually maybe all the grading tests we have. But anyway, so you must have a sense about whether your system is working by running enough number of test cases. So before that point, it would be okay to have so many changes touch upon the open part, also so many changes touch upon the pink one, the pink part, the closed part as well. That's okay. Before you get to the working version, you're still trying to stabilize both parts. But once you pass that threshold, and then changes to your system should mostly be the open part. And then there should be rarely some changes on the closed part. So that would be the more acceptable scenario. So Amir, if you're still here, so does that answer your questions about open-close principle? All right, very good. Okay, so now Jahao got another question here. So all the principle have a, Amir, I'll get back to you about teamwork. Just give me a moment. So Jahao got a question here. So all the principle have a precondition that the work is done, and when we are trying to make a modification, not necessarily all the, yeah. Okay, think about this. I can see where you're coming from. Think about this. Think about this a timeline for your projects. Think about this might be your version number 1. This might be your version number 2. This might be your version number 3. Okay? Think about this is like a submission deadline. And let's not be so restricted about just submitting for your grading. Let's say you're in your workplace. Your supervisor might just give you some development task to say you should really get this done by, for example, December 31st this year for your team, right? In that case, I would say before the submission deadline, it would be okay for the intermediate versions over here to violate certain design principle because nobody really reviewed that formally. However, this is really the point. When you actually submit this for either for your supervisor's approval, or you want to submit this to your colleagues in the workplace so that they can take your code and develop further. So this is the point where design principle should be satisfied. Should be satisfied. Let me just write it a bit properly. Okay, should be satisfied. But before that, all the intermediate ones, that's okay. All right. So Jahal, does it make sense to you? The main thing about this point here, it really is you don't really aim for perfection about the very first version of your project. So before your submission deadline, for whatever purpose, it's okay to really have imperfection, to really have some evolution of your project, as long as eventually you can submit as perfect as possible, right? Okay, okay, one more question from Amir. Okay, that's about this part here. He also mentioned that I just forgot. In a teamwork projects, how do we follow open-close principle? I would say it's kind of similar, okay? Think about in a teamwork. Let's say you got a team of however many people. You guys might just have some initial meeting to talk about the requirements for the game or for whatever development task you're given. And then think about the entire system goes like this. First of all, think about which part of the system should be subject to open-close principle and which part should not be subject to open-close principle, right? Number 1, which part should be subject to open-close principle, and also which part should not be subject to open-close principle, right? So once you guys decide, whoever, whichever team members might be who might be assigned to this part here, they don't have to worry, right? And whoever might be assigned to really work on this part here, they should worry further, right? So now, number 2, for the part that's subject to open-close principle, you have to make a decision about, for this part here, since the whole team decided that this part should be subject to open-close principle. So what should you do? Well, you should really decide which part should be open, which subpart should be open, and also which subpart should be closed, right? And then once you decide, once you're done, you can go ahead and to implement these and then individually, and then eventually will integrate together. So Amir, does it make sense to you? All right, good. All right, guys, we're pretty much running out of time. Do you guys have any final last minute questions for me about week number 11, Visitor Design Pattern? Any other questions? All right, so we got one more Q&A tomorrow. So if you got more questions, feel free to put on the Google Doc or just come and then ask me on the chat or just speak up. All right, thank you for coming, and then have a good night. I'll see you tomorrow in the Q&A. All right, I'm going to end the recording right now. Take care.